Hello friends, welcome to Suresh Aggarwal's Mathematics Shortcuts. LCM and HCF of numbers. We learn that at class 5, 6 level, and the students follow those traditional methods in higher classes as well. This has to be simplified, and especially when LCM and HCF are to be found out for not whole numbers but decimals and even fractions. Can you tell me a way through which you can find the LCM and HCF of these decimal numbers? And that is what is the intention of bringing up this video for you. This will tell you how to find the LCM of decimal numbers. Very interesting, very important video, and you need to watch this, and after watching, practice and share it with your friends so that they also see the beauty of mathematics. This topic is from chapter number 6 of our ebook of short tricks, Conquer Decimals. So we are trying to conquer the decimals. We are trying to rule the decimals so that they no longer trouble us and there are no silly mistakes in the exams related to this important topic of decimals. Decimals are everywhere, physics, chemistry, everywhere. Wherever there are numbers, there are decimals. And so being comfortable with the topic is really important. So if you want a compilation of 350 such short methods, these are contained in the ebook of short tricks, and you can get a copy of that by sending me a message on WhatsApp. This is the WhatsApp number 9896369963. You can copy it from here or see all these details are in the description of this video as well. So friends, let's first see some basic examples, and then once we are through with the concept of finding the LCM of decimals, we will take up the big examples also, right? So the first question I am going to take up is 0.6 and 0.4, 1.2 and 0.8. Easy questions first, and that helps us in building the concept. So the first thing I have to observe in decimals is how many digits it has after decimal. If the numbers in the question have equal number of digits after decimal, just forget the decimal. Okay, so here 1 digit and 1 digit, equal number of digits, just forget the decimal. So this is 06, which is just 6, and this is 04, which is just 4. Now everybody knows what is the LCM of 6 and 4, right? Because 6 and 4 doesn't divide 6, so 6 cannot be the LCM. So I have to take the next multiple of 6, which is 12. Now 4 divides 12, and therefore the LCM of 6 and 4 is 12. Now the LCM of 0.6 and 0.4, because both of them have 1 decimal places, your answer here will also have 1 decimal place, and so the answer is 1.2. I have just put a decimal 1 digit from the right hand side in 12, and I got 1.2 as the LCM. Likewise, 1 digit here, 1 digit here, no problems at all. Forget the decimal, 12 and 8. Now the first thing is to know what is the LCM of 12 and 8. 8 doesn't divide 12, right? So let's take the next multiple of 12, 24. 24 is divisible by 8. So LCM of 8 and 12 is 24. So I know most of you have guessed it already. The LCM of 1.2 and 0.8, because both of them have 1 decimal place, put a decimal 1 digit from the right hand side, 2.4 will be the LCM of these decimals. Sounds easy, like, but what happens, when you do more questions of different models, different types, there comes the complexity. Let's see some more questions. Here we have 1 digit after decimal and 2 digits after decimal. So what do we do here is, the first thing you have to understand is 7.5 is to be written as 7.50. Okay, and then you have the next number 0.25, which already has 2 decimal places. So I just equated the number of decimal places, and now I am going to forget the decimal. So 7.50 is 750 and 025 means 25. Now 25 divides 750 exactly. So the LCM of 750 and 25 is 750 itself. But you have to put the decimal at the right place now, because two decimal places here, two decimal places here, so two decimal places here also, and therefore the required LCM will be 7.50 or simply 7.5. If there are three numbers, the method doesn't change. You can see one digit after decimal, 2 here and 2 here. So let's convert this to two decimal places, 0.60, and then these two remain the same. Now forget the decimal, 060 is 60, this is 12 and this is 18. Now I have to first find the LCM of 12, 60 and 18. Now how much is that? 12 divides 60. So let's forget 12 as of now for finding the LCM. The factors are never considered, okay? So 18 and 60, okay, so they are divisible by 6. So which gives me a 10 and a 3. And 10 and 3 are co-prime, right? So 10 times 3 is 30. 30 into 6 is 180. This is going to be the LCM of 60, 12 and 18. Now two decimal places. So the required LCM will be two decimal places, 1.80 or simply 1.8 is the answer for this particular question. I can go on and on, let's take more examples, but you need to practice yourself. I can demonstrate using some more examples. Let's see here. One decimal place, 2 here and 1 here. So let's write 0.10, 0.05 and 0.30. Now forget the decimal. This is 010, 10. This is 0055 and this is 030, 30. Now 5 divides 30, 10 divides 30, so cancel both of them. LCM is 30. And if the LCM of these numbers is 30, I need two decimal places, right? So put a decimal 2 digits from the right hand side. The LCM of the required decimals is 0.30 or simply 0.3 as the answer. Likewise for this question, if you see carefully, this is one digit and one digit. So forget the decimals, 32, 48, 64. Now I need to find the LCM here. So for finding the LCM of these numbers, I can see 16, 2 times is 32, 3 times is 48 and 4 times is 64. Now for LCM of these three numbers, 2 is ruled out because it divides 4. So this is 16 into 4 3s are 12, which is 192. Now the LCM of 32, 48, 64 is 192, and therefore the LCM of required numbers, how many decimal places? 1, 1 and 1. So one digit from the right hand side, 19.2 is the LCM of these numbers. So the concept is really important, and once you understand the concept, start applying it and solve 40-50 questions, you will realize it is not that difficult. So friends, if you like this video, do share it with all your friends on various social media platforms. Pick up the link, share it on your WhatsApp groups, your broadcast list, Instagram, Twitter, wherever you want to see people coming in and enjoying the beauty of mathematics. Share it there, that will be a great help. And I hope you have subscribed to our channel Suresh Aggarwal's Mathematics Shortcuts, and you have clicked the bell shaped icon. Very, very important. People subscribe the channel but they don't click the bell icon because somehow they don't know about the importance of clicking this bell icon. It helps you in getting the notifications of the uploads on your mobile itself. So friends, please click that, and I hope this video works well for you. Do practice 30-40 questions and tell me in the comments below, did it work for you? All the best.